Hi there. In this last section from Chapter 7, we're going to be talking about probability and percent chance. This is a pretty straightforward and short section. So the objectives are to understand experiments, outcomes, and events. That's more just a conceptual thing. Find the probability of an event and the percent chance, and find the complement of an event. So the first thing you need to do is learn the terms. So an experiment is an activity with an observable result. It's a little different from a science experiment, but it's the same kind of idea. The outcome is the result, and the event is any outcome or group of outcomes. So that's the event from the experiment. So some examples of experiments and their events. Tossing a coin and observing whether it's going to be heads or tails. That's the experiment. The coin comes up heads. That's the event. So, or if it came up tails, that would also be an event. Observing the weather and noting the precipitation. And an example of an event would be at the moment of observation, it is raining, or it is windy, or something like that. Examples of experiments with die could be rolling a 6-sided die and observing the result. You can also have a 4-sided die or a 12-sided die. And an example of an event would be a result of 1, 3, or 5 when the die is rolled. It could be a result of even numbers when the die is rolled, that kind of thing. All right, so let's look at an example. So we've got a 4-sided die, the one shown below. When you have a 4-sided die, the one that turns up is the one that's facing downward, actually. So list all the possible outcomes for the experiment when a 4-sided die is rolled. So all possible outcomes would be 1, 2, 3, and 4. That's pretty much it. So now you try it with all possible outcomes for a 6-sided die. So the result of that would be that all possible outcomes for a 6-sided die are 1, 2, 3, 4, 5, 6. So you don't want to say 1 through 6, you want to actually list every possible outcome for those kind of problems. Okay, so here I have some concepts and vocabulary for probability. The probability of an event is a measure of its likelihood of it occurring. It must be a number between what and what, do you think? So it needs to be a number between 0 and 1. Okay, this can be written as a decimal. It can be written as a fraction. And it can also be written as a percent. So remember, a decimal can just turn into a percent by moving the decimal place over 2 places to the right, or multiplying times 100. So 1 means that you have a 100% probability of it. It's definitely going to happen. And 0 means you have a 0% probability. There is absolutely no chance that it will happen. Okay, so those are the two definite parts of this. All right, a percent chance is a probability written as a percent. So if you've got, say, for instance, a 0.23 chance of it happening, as a percent chance, it would become 23%. All right, so just some examples. These numbers represent probabilities, 0, 1/2, 0.65, 30%, and 1. These numbers down here in red do not represent probabilities, and it is because they're not between 0 and 1. If they're a percent, they've got to be between 0 and 100%, and if they're a number, they need to be between 0 and 1. They can't be negative, and that kind of thing. So those are not probabilities. All right, so the way we figure out a probability of an event happening is we look at the number of ways the event can occur, all the ways it could possibly occur, divided by the number of possible outcomes of the experiment itself. Okay, so ways of the event could occur divided by outcomes for the experiment. So this gives us a theoretical probability based on the idea that all outcomes are equally likely. So this is not true if you have like a weighted coin or die. So it's got to be a fair coin. Everything needs to be equally likely to occur. So let's look at a couple of examples. Okay, so this example is computing probability when tossing a coin. And most people can do this problem just intuitively, but I want to show you how we use the idea of probability, the probability formula. So we want to find the probability of getting heads when a coin is tossed. So we want to look at the number of ways the event can occur. So looking at probability of heads, number of ways the event can occur. So there's only one choice of getting heads. So there's only one way for that to occur. So we're going to have 1 on top. And then the number of possible outcomes of flipping the coin. Well, there's 2 outcomes because there's 2 sides to the coin. So 1/2. So that can also be written as 0.5 or as 50%. Okay, so this next question asks us to find the probability that a number greater than 4 results when a 6-sided die is rolled. So what does greater than 4 mean? That means that we've got 5 or 6. Okay, so 5 or 6. So how many ways can our positive result happen, the thing we're looking for? That's 2 ways, either a 5 or a 6. The number of possible outcomes of a 6-sided die is 6 different ways. So we've got a 2, 6, and we always want to reduce it when we have a fraction, so that's a 1/3 chance. So simplify the fraction. Okay, and you can put that in and do 33.33% if you'd like to, but the more exact answer is 1/3. All right, so why don't you give this next one a try? So this one asks us to find the probability that a prime number results when a 6-sided die is rolled. So first you have to figure out what the prime numbers are, and we get that the prime numbers are 2, 3, and 5. 1 is neither prime nor composite, by the way. So there are 3 different ways to get a prime number. So we put a 3 on top, number of ways the event can occur. Over 6 is a 6-sided die, so there's 6 possible outcomes, which is 1/2. Okay, so at this point we are going to look at some cards. So first I wanted to show you what a suit of cards looks like, because you're going to see a lot of problems and a lot of people don't actually know what a suit of cards looks like. So here's the information you need to answer these questions. You can pause the video and read this right up here, but I just wanted to show you that there are 4 suits. This is clubs, spades, hearts, and diamonds. Each suit has 13 cards in it. It goes from ace, which can be at either end. It can be high or it can be low in different games. It can be a 1 or it can be above a king. And it goes up to 10, and then there's the jack, queen, and king. So the jack, queen, and king are known as face cards. So these down here are called face cards. Okay? So make sure you understand that before you answer any more questions. Okay, so all of these questions are going to be about the deck of cards. So a single card is randomly drawn from a standard deck of playing cards that's been shuffled and all that. Express your answer as a fraction. What is the probability of getting each of these things? The first one is the king of clubs. There is only 1 king of clubs in the entire deck. So you're going to get 1 over, so there's only 1 chance of getting a king of clubs, over the all the possible chances of all the cards. So how many cards are there total? And if you look up above, if you don't know, it's in the information I just gave you, there are 52. So that can't be simplified, it's 1 over 52. All right, a red 5. So I'll actually go back up here so I can talk about this. How many red 5s are there? Well, there's only 2. There's the hearts and there's the diamonds. So there's 2 red 5s. So 2 out of 52 choices. Okay, so that can be reduced to 1 out of 26, or a 1 to 26 chance. All right, a face card. What is the chance of getting a face card? So how many face cards are there? Well, there's 3 by 4, there's 12 here. So 12 opportunities to get any face card out of 52. Now we're going to reduce this by dividing top and bottom by 4, so we get 4 times 3 and 4 times 13. So the 4's cancel out and I get 3/13. All right, so the next 3 I would like for you to try, and you can go and look at those, the picture of the deck of cards if you would like. Okay, ace of hearts, there is only 1, so 1 out of 52. A red face card, there are 6 red face cards. So that's these right here, 6 red face cards. So you would get 6 out of 52. Reduce that and get 3 out of 26. Diamonds, there are 13 diamonds. There are 13 spades and 13 clubs and so on. So there's 13 diamonds out of 52 reduces to 1/4. Okay, so the last topic is finding the complement of an event. So the complement of an event includes all the outcomes of an experiment that are not part of the given event. So if I told you that 25 out of 30 chairs are occupied in a room, the complement of this event would be that 5 chairs are not occupied. So we've got some examples here. Rolling an odd number on a die is the event, so the complement would be rolling an even number, all the other numbers. The event of getting tails in a coin toss, its complement would be getting heads. The event of drawing a club, spade, or heart, the complement would be not drawing that, drawing the other thing that's left, which is a diamond. Okay, so the probability of the complement is 1 minus the probability of the event. Or if it's percentage, the probability of the event's complement in percents would be 100% minus the percent of the event. Okay, so we're going to use this given information to answer these questions. So if there is a 30% chance of rain on a given day, what is the chance of no rain? So you're just going to take 100 minus percent minus 30% to give you 70%. So there's a 70% chance of no rain. Okay, the second one, the probability that a student will pass a test is 43 out of 50. What's the probability that they will not pass the test? So we're going to take 1 minus 43 fiftieths. And if you want to just change the 1 to 50 fiftieths, you're going to get 50. Let me redo that. I'm just going to say, I'm going to rewrite this. 50 fiftieths minus 43 fiftieths is going to give us 7 fiftieths. Okay, so that's about as difficult as the complements get. It's more understanding the question. So make sure you read the question carefully. All right, so there's a couple more here, and this is the last part of this lecture. Give these a shot. Okay, hopefully you tried these, but A, you should get 65% chance that he will not get a hit, and the probability of not drawing a card that is an ace is 12/13. So you can just take 1 minus 1/13 is 12/13. All right, that's the end of this lecture. Thanks for watching.